5.3b. What we're going to do here is we're going to do some applications, and the applications, what they're doing is they're giving us some formulas. Area equals S squared. That is the area of a square. So if we have the area, or if we have a square and we're looking for the area, and this is 6, what we're going to do is this S represents a side. We're going to put the 6 in here. 6 times 6 is 36. That's my area. So that's the area of a square. The other formula that they give you at the bottom of page 372 is A equals length times width. And length times width is used for a rectangle. So for example, this were 6 and this were 2. Length is 6, width is 2, and it doesn't matter if the length is 6 or the length is 2. You're going to multiply the two numbers. You're going to go 6 times 2 or 2 times 6. You're going to get 12 either way. So that's the area of a rectangle. And that brings us into doing some things with circles. I haven't done much with circles, but we've got a formula for the area of a circle. Area of a circle, I put a dot there so that it's a circle, not a 0. The area of a circle is pi r squared. R represents the radius. The radius, if you remember, of a circle is the distance from the center point to any other point on the circle. So that distance is called the radius. Also, the distance all the way across through the diameter, or through the center point, is called the diameter. Notice that the diameter is twice as long as the radius. So, if we're given the diameter and we want the radius, we take half of it. If we're given the radius and we want the diameter, we double it. So if this were 3, this would be 6. If this were 8, this would be 4. Pi is a number. It never changes. For our intent, or our purposes that we're going to use, we're going to make it 3.14. That number is always 3.14, yet it is a decimal, and that decimal does go on and on and on. It doesn't just stop at 3.14. But for what we're doing here, we're just going to go ahead and leave it at 3.14. So every time you see pi, put 3.14 down and go ahead and multiply. The other part we have for a circle is called the circumference. Just going to write circum of a circle, and that formula is 2 pi r. Alright, so circumference means the distance around. Just like we had a rectangle and we said how much fence is it going to take to go all the way around this rectangle, circumferences of a circle means we're going to start here. How much fence do we need to make this circle and get back to where we started? So circumference and perimeter are the same thing. It's just circumference has to do with circles and perimeter has to do with polygons, things with actual sides to them. So let's jump to page 374 and look at example 13. And they're asking you to find the circumference of a circle if you know that the diameter is 5. Okay, so if the diameter is 5. So the formula for circumference is 2 pi r. Okay, there also is another formula for circumference. Let me put that down. And it's pi d. The d represents the diameter. So you can either use the r and multiply it by 2, or the d and not multiply it by 2. In this case, the diameter is 5. So we can use this formula because we're given d. So all we have to do here is rewrite this as 3.14 times 5. Multiply that through and get the answer, and we get 15.7 when we multiply these two. So that's using some formulas. We'll do a couple more here real quick. Some of the formulas are on top of page 374. That's the circumference. Some areas are in the green on page 375. So let's look at example number 15. Find the area of a circle with a diameter of 10 feet. So we've got a circle. The distance all the way across is 10. And they're asking us to find the area. So I know the area of a circle is pi r squared. That being the case, I know this is 3.14. And my r, I don't know, but I do know the diameter. And I know that the radius is half of this diameter. So my r then is 5. Well, what does it say to do with that 5 here? It says square it. So 5 times 5 is 25. So now what I'm going to do is multiply 3.14 times 25. If you look at example 16, 16 gives you a drinking straw. In fact, it's not only a drinking straw circumference they want, but they're going to want the volume. Now, if you look at the top of page 375 in green, on the right they have a circular cylinder. It looks like a pop can, looks like a straw, whatever. But the way you find the volume of that, how much air is in that, how much water you can put in there, you take the area of the base, or of the bottom, which is pi r squared, because it's a circle, or I'm sorry, that's the area, and then you take that area and multiply it by how high it is, or in this case, how long it is. So for example, in the straw, if I say that the straw is 6 inches long from here to here, and I say that my radius, so that would be the distance from the center here, is 0.25. So I'm saying my r, or I'm sorry, 125. I'm saying my radius, always helps me to write this, so I put my letter with what it represents, 0.125. My height, or the length, whatever, is 6, and I know my pi is 3.14. So I have all the information I need. Now, according to the formula, all I do is multiply those. 3.14 times 0.125 times the height, which is 6. In volume, we'll always include multiplying 3 numbers together. So, multiply those through, and that will give us our volume, which is at the bottom of the page, 375.294. So we multiply these, then that answer, and multiply it times 6, and we get 0.294. One thing that I did miss up here, though, if you notice, I've got the radius here, and see, the radius is squared, and I didn't put my 2 up there. So what we're going to do, first of all, using PEMDAS, is my exponents. We're going to multiply this times itself, and, well, let's just look at the book and write down what they've got. 0.15625. Then we're going to multiply that times 6 and 3.14. It does not matter what order you multiply these in, as long as you multiply all 3 of them. So you multiply those together and you get 0.294, and you get cubic inches. You get cubic inches because you're dealing with volume. Volume always is in cubes because there's 3 dimensions to volume: a length, a width, and a height. So that's it for multiplying decimals. Problem set on page 377 does the exact same thing that we just did. Not really any need to go over that problem set. There are some examples in the section prior that we just did that I didn't get to, and there's also well, 1 through 28 you're just multiplying. 29 to 48 you're just following the instructions using PEMDAS, doing what's in the parentheses first, and if you got to multiply that answer times something, do it. Add or subtract it to something, and you're good to go. So go ahead and turn this off, and we'll head into 5.4.